Well, now I'm really pleased to introduce you Tim. Tim is another Brit like me who has escaped the flaming hellfire that is the UK for sunny Barcelona. He's the tech lead and the open source champion at Softwire. One does wonder what you have to do and who you have to beat in order to become the champion. And so promises are something that we hear a lot about nowadays, making code sound somewhat relationship related. I won't hold you up any further with my stupid analogies. Please put your hands together for Tim Perry.
Thank you. Okay, we've heard a lot of really fantastic talks so far about design and technology. I am not a designer. This is going to be a fairly technical talk, and we're going to be digging into a lot of code. I don't really know very much about UX strategy or about art design, but these talks have been really fascinating for me as well anyway. I'm not really looking at kind of engaging your users with the deeper message behind your brand, trying to really help people understand the story behind your product, but I am looking at how to get other developers to understand the deeper meaning behind your code. This is going to be a talk about new technology in JavaScript, about better ways to write code. But really, this is a talk about better communication with your fellow developers, better ways of expressing the actual meaning behind what we're trying to build. Some context first. I work for a company called Softwire. We build products for other people, big people you've heard of, like Cisco and the BBC, and loads of other smaller ones. And at this stage, the internet has become quite popular, so a lot of these have web front ends. A lot of this is big front-end JavaScript applications, and that's only becoming a larger and larger part. And building these requires that we're building deep, interactive code that is going to give the kind of experiences that these users are really looking for here. We need to be able to manage large code bases, and to us it's really important that we can maintain these effectively. We have to be able to move quickly within these. We have to be able to build new features on top. We need to be able to support these, and when we hand this code off to our clients, often they need to be able to support this code. So it needs to be easy to understand, easy to quickly change and work with. There's a great quote from Martin Fowler: "Any fool can write code a computer can understand. Good programmers write code a human can understand." Writing code for computers is comparatively easy. I don't know how many people came to Vitaly's talk yesterday, but there's some great examples there of how you can solve some really interesting problems in responsive emails with crazy tools in crazy ways, and you can still get the computer to do what you want it to do. If you try and write that code and then ask a human how it works without an excellent talk explaining it, you're going to have real trouble. Trying to actually get that meaning, the overall structure communicated through in your code, is a really hard problem. And this is our goal for today, to take the models you're using when you think about your code, your idea of how your code works in your head, and translate that into code that lets other developers build those same models as quickly as possible. Bring the ideas you're using when you write your code into other developers' minds as they try and read it. We're going to be talking about JavaScript. We're going to be digging into a lot of JavaScript code. I'm not going to assume too much familiarity with the ES6 stuff, so I'll try and explain the newer bits as I go. If I'm going a bit too fast, just try and look kind of scared and panicked. If you fall off your seat, I'll know I've gone too far, and I'll do my best to try and slow down and keep everybody seated, or just wave. We're going to be looking particularly here at how we can express async processes. And by that, I mean a series of non-blocking operations. So I'm going to do something, that's going to start a process in the background. I'm going to do some things in the meantime, and then maybe do something when that other process finishes. So we've got processes that we're not just locking everything down and waiting for, non-blocking operations. This happens a lot in the front end. We load some data, and then you want to keep your UI interactive. Well, that data comes and loads. Perhaps you're going to show a nice loading spinner, and then you want to do something when the data comes back. Perhaps you want to start an animation and do something when the animation finishes. Waiting for non-blocking processes. This is a fundamental part of writing good front-end code. We can't do the kind of classic models you would for simple programs in other languages where you just start a process and it blocks and you wait. We have to have these very, very interactive, very usable interfaces, and blocking code breaks that. So you need to be writing async code pretty much all the time in JavaScript. And to make your JavaScript readable, you have to be able to work with that really well. And JavaScript runtimes are pretty good at doing that, but I don't think they're great. Fundamentally, JavaScript runtimes, compared to other languages, have removed a lot of the big async challenges with writing this kind of code, but haven't actually given us any clear ways to express it until now. The challenges point really is two key technical features that come in with our JavaScript runtimes. Firstly, the overall process is event-driven, it runs to completion, and it's on a single thread. JavaScript runtimes you're used to have an event queue. They have a series of events they're going to handle. It's a single thread that picks up an event, runs the code associated with it, runs that until that calls more functions, and those all return until they're completely done, and then we pick up the next event. We just do this with a single thread in the series, handling one event at a time until it's totally done. That compares to other languages where you have a single process, and when it's done, the program is probably done for a single-threaded application. And if you want to run multiple tasks at the same time, multiple longer-term processes, you run actual separate threads. You have one thread that starts off, makes a request, and sits there until the request comes back, and another thread that manages some UI stuff, and then the request comes back, and the first thread continues, and we've got this multi-threaded blocking process. And that works well in these kind of environments, but has a lot of extra complexity that we've got rid of in JavaScript. We're getting concurrency instead of having threads running in parallel and interleaving lower-level operations, interleaving individual tiny parts of how they work, add these variables, write to memory, read from memory. Instead, we interleave purely at an event level. We handle an entire event, and then we're done, and then we handle the entire next event. And that makes concurrency much, much easier to understand in JavaScript. You've never really written any JavaScript where on one line you read a variable, on the next line you write the variable, and somebody else might have changed it in the meantime. That just doesn't really happen in normal code. And if you're running code in lots of other languages, that is a big problem. So we've solved some big concurrency challenges by building this model. But it's important to note this model is part of the runtime. This is not in the JavaScript spec. You could write a legitimate version of JavaScript that does not do this. This is part of the HTML specs. This is part of how browsers work, how V8 and so on work. And because of that, the language doesn't actually have any support for it, doesn't have any direct interaction with it, because it doesn't know that it exists. The other good thing we have that helps support this is the community, the ecosystem, the tools we've built. As a group, we've all decided that a really good idea would be to do async pretty much everywhere. You just don't find APIs where you call it and it says, OK, this function call might take 5 minutes. That doesn't happen. That would be very bad. By and large, you can trust that almost any API you want to use has a non-blocking option available, and you're going to be able to just use that and just go. And you see people trying to write non-blocking asynchronous code in other languages where this isn't the case. If you're trying to do non-blocking I/O in Python or in Java, you spend a lot of time wrapping other APIs that don't yet support this to make them non-blocking and fighting with that. And again, that's a problem that in JavaScript just doesn't exist. So we're in a pretty good place, fundamentally, structurally, for getting this stuff done. We've made a lot of this async non-blocking process much simpler. We've taken away big problems. But it doesn't actually make it easy. The runtime is better, the overall fundamental model is better, but in the actual language, we can't directly express this stuff. We're trying to describe these processes where we say, I want to do this, and then once that process finishes, I want to do this. I want to run these things in parallel and then wait for the result together. And until very, very recently, we didn't have direct tools to do that. The big tool we have in JavaScript is these very nice, little lightweight, easy functions that we can quickly define and pass around, and we use those for pretty much everything. And it turns out that we can also write async processes pretty easily with those. They're a good tool to get stuff done. But just because they're a good tool that lets you, with a bit of fiddling, solve this kind of problem, doesn't mean they actually work well for this. When you write that code, the runtime doesn't really understand what you're trying to do. It just happens to work out. You're not sure it's going to work. It's going to work because the libraries you're using normally follow the right kind of conventions so that you expect callbacks to work as you're used to. And people reading your code don't know necessarily exactly what it's going to do. They can make a good guess on the kind of overall structure, but you're repeating these same ideas. This is a bit vague, but we'll get into some more concrete examples in a minute. What we need to do this better, though, is really high-level, built-in constructs that actually express what we're trying to say. Not tools we can put together that give us the right overall answer, that make the computer work correctly, but tools that explicitly say the actual patterns we're trying to do. I think a really good parallel is the move from go-tos towards modern control structures, if and for and while. A big shift within this came in 1968 when Dijkstra published Go-To Considered Harmful. At the time, a lot of code was written as a long, long series of instructions with a lot of go-tos that jumped between labels within that. And Go-To was an effective tool that could get this kind of stuff done. You could write big, complicated programs doing this. But underneath, really people were just using very standard patterns. One of the clear big things that Dijkstra brought out was that most of the stuff we were doing with go-tos, actually, what you're really trying to say here is, if this is true, then run this chunk of code. While this is true, then repeatedly run this chunk of code. There's standard patterns and ways that we're trying to describe programs that we didn't have explicit constructs for. We didn't have tools to accurately describe, and we'd munge together something that would work. And we added constructs, and we've improved our code by doing so. So until now, the best tools we've had for this kind of stuff has been callbacks. Callbacks are two low-level constructs that doesn't really say what we're actually trying to do. We're somewhat abusing first-class functions to get the behavior we want without really explaining what's going on. If we actually try and think about how we might describe these programs to other people, you might get something like this. I want a program that does a series of operations in sequence using the values from the previous operations. A series of sequential operations, each of which is non-blocking. If you want to actually write this code in callbacks, you might have to write something like this. This, I would argue, is not particularly readable. There's a lot of mess here. There's a lot of noise. To actually work out and translate back to that previous model, to what I was thinking when I wrote this code, you have to read around a lot of the mess here. You have to look at that and be like, oh, OK, I know this means this is a callback that's going to happen asynchronously. I know this is error handling, so cool, that must mean this is the important bit, and I should just skip past the rest. And as you read it, you can feel your mind just skipping over the irrelevant bits and trying to focus on where the actual logic is in this code. There's a lot of extra noise and extra mess. A lot of that here comes from error handling, particularly. This doesn't actually even catch all the errors. In a nice, good environment, you'd expect none of these functions to ever throw synchronous errors, but lots of the time, people screw up or don't even think about this, and they do. And if, say, getBestFriend or getBestPhoto here synchronously throws an error, then within that callback, you'll throw an error, you'll explode, and this will just disappear. You won't get any response. Your original top-level callback won't get called with an error. This will just die. If you want to handle that better, you need to put try catches around each of the individual operations in there, which looks something like this, which might be a bit unreadable at the back, and that's kind of my point. This isn't a reasonable way of writing code. Right? There's clearly problems here, and you can, I'm making a terrible example here. You can do this better, you can structure this better, but fundamentally you end up having to try and solve this problem. You have a big, horrible mess, and you're trying to use very simple tools that don't really understand what you're trying to do, so you have to keep trying to fight them over and over again to express what you really want to do. And this really doesn't match at all the description that I would use in words, the way I would communicate this to a person if I were just trying to describe this program. And we'd like to get closer to that. Our current best option for this is promises. Promises came in with ES6, now called ES 2015. Who here has actually written some code using promises? Yeah, it's pretty good coverage. OK. So we'll do a very quick recap. Promises are a representation of an ongoing process. Okay? They're an object that describes a series or single operation that may or may not yet be finished, but hopefully is later going to be finished. They have three possible states. They are pending, and then eventually they either fulfill with a result or reject with a value. We can build them fairly easily. We've got a promise constructor that takes two callbacks for resolving and rejecting, and you define a promise by calling this, and then inside that code, doing whatever you like, and eventually calling resolve with the value that you want this promise to fulfill with, or reject with an error that you want it to fail with. And we've also got these two convenient other constructors at the bottom to define a promise that immediately resolves or immediately rejects. Once we've got this representation of a process, we can start following the patterns we were talking about earlier. So, for example, we can chain together a series of operations in a much more fluent and effective way. Load data returns a promise, and then once we've got a promise, once we've got this representation of an ongoing process, we can say afterwards, do this, transform the data. And then once that's done, show the data. And the value that load data resolves with becomes the argument to the then. And the value that transform data eventually resolves with becomes the argument to the next then. And that return transform data is either returning a direct value. If transform data is synchronous, it might just return an object. So that then step returns an object, and that immediately calls the next then step with that result. Or transform data can return a promise, and that promise in turn will be waited for, and then call the next then step. And we'll resolve it down to a real value. So we end up just working with the final values of each thing in a series of then steps. And we can describe a series of nice asynchronous operations in a better way. This lets us start to write the previous code in a much clearer way. And we can also improve error handling drastically. We can put catches at the end. And this has the same kind of model you're used to from try-catch. If an error happens at any point previously during this promise chain, then the catch picks up that error. The error ends up in the first catch that it comes down and reaches, and you can handle it. And you can have a single catch that covers a whole bunch of different steps, hugely improving that previous horrible mess we were looking at. So this lets us cover some core essential patterns and is a lot better. It also allows us to do some new patterns. So, for example, promise.all. We can define a few promises and say, I'd like an object that represents when all of these promises are finished. So I want to get a promise back that is pending until all of the promises I've given you are done, and then gives me an array with the results of each of these. So here, this is going to load 2 bits of data, and when both of those bits of data are ready, the next step in the chain, the argument to then on this all data promise, would be given an array with the 2 results of load data 1 and load data 2. And we can also do promise.race to kind of do the opposite. We can take 2 promises and ask to be given the value that resolves first. Whichever one is finished first, give me that, and I don't care about the other one. We can just put 2 promises against each other and get a single promise that represents the combined result. So this is our current best solution up until year 6. Ready? This has a good, reasonable API that solves the challenges we've been looking at. You can express those patterns better. You can say what you actually mean. And more importantly, gives us a concrete representation of this. There's 2 parts to promises. We've got this API for how we actually define them and manage them, and then underneath we've got these objects that represent something that was previously totally implicit. Up until this point, asynchronous programming was really just in your head. Now you've got an actual thing you can pass around that says, here is my asynchronous process that is maybe still running or maybe finished, and you can start changing that. You can say, after it's done, I'd like to do this, actually. So we've gained this extra tool, this extra representation. There's still a lot of ceremony here. We're wrapping a lot of things with functions. We've got a lot of extra then and catch and so on. And there's some things you can do wrong. If in that previous example you don't return transform data, then you'll accidentally not wait for it and you'll just jump on to the next step. And if you fail to catch, you can still miss errors, although dev tools are getting much better at that. And there's still more than we'd like. It's not as clear as how I would just describe that code to another person. And that's really what I'm looking to get towards. More importantly, though, we're tying function scopes to async operations. This is more complicated, and we'll see some examples in a sec. But fundamentally now, if I have an async operation, it has to divide 2 function scopes. I cannot have a single function scope that covers an async operation. And that's a big problem because everything in JavaScript is based on function scopes. Our variables live and die in function scopes. Our control structures only work within a function scope. You cannot have a for loop that starts in one function and finishes in another. That's not a thing. That doesn't make any sense. Here, we've ensured that means you cannot have a for loop that goes around an async expression because we've tied these 2 together. They're now working in lockstep, and that limits us in a bunch of ways. Let's imagine you want to combine the results of two sequential operations and use that in an if. You want to go, if this is true and this is true, then do this. That's something that I can easily explain. Nope, sorry, that's the wrong example. Imagine you want to do two sequential operations and then get the results of both of them together. Imagine you want to get a user data, get some information for that user using that user data, and then put both of those bits of information on the screen. Because of the way that scopes work here, that means in promises you have to write this. You have to pull out a global variable and then manually kind of export out to the global variable when you get given some information in your first step here, and then eventually use both at the end. This isn't that bad, but it's pretty messy. There's this extra line in here that doesn't really tell me anything about what the program is doing. It's just extra mess, extra mechanisms that I have to understand rather than real meaning behind your program. There's an alternative to this where instead you build composite objects and pass them through, which looks like this. I don't think this is particularly nice either. Here we move another promise and nest it inside, and that allows us to keep both of these variables in scope, but still limits us to a degree, and we have to pull things out of the object at the end, and it's all a bit messy. And this is because our variable scopes are tied to these individual functions. We can't have a variable that lives in two separate sections with an async operation in the middle, unless it's totally global. Similarly, if we want to do async in a loop, perhaps we've got a list of tasks, we want to run each of them in series until they're done, and then we want to get an array with all the results of them. That's a thing I can explain to you in maybe 1.5 seconds. We can time it if we've got some spare time at the end. This is pretty clear and easy. It's a common pattern. This is a common structure that you'd like to be able to express really, really succinctly. And if you want to do this in promises, you can do something like this, which I would argue is not clear and succinct. If anybody's managed to understand that in 1.5 seconds, do let me know. What you have to do here is start with a promise with your list of results, and then in a loop, and the loop has to finish before any of the promises can start, because they have to be asynchronous. You build up a chain of promises, and within that, you run each of the tasks, and within that, after those, you combine the results together. And you end up building a chain of promises that is run task, remember result, run task, remember result, run task, remember result, return the whole lot. And you build that whole chain at the beginning, and then you return it at the end. And it's a mess, and it's confusing. And I can still see people looking at this being confused. And that's what's supposed to happen. This is confusing. This is not a good way of expressing what we're trying to do. Finally, one last example of where promises really fall down here is what I was talking about before. If we want to do a conditional on 2 async operations, or even just 1 async operation, you can't. You can't have if async operation completes, then do something, because an if must start and finish within 1 function scope. So if we want to write this code, if the server is up, and separately if my login is valid, if these 2 asynchronous checks are OK, then go and save some data and show a nice message, and otherwise complain. The actual promises for this looks like this. We, if server is available, return a promise, and then once we've got server available, return server is available, and is authentication valid? And we do some interesting shortcutting here to make sure that we only actually return a promise there if we still actually need to do the second check. And then we come to the second one with a Boolean that ends up representing them both, and we've kind of combined them along the way, and then we can check this finally, and we can do the if. And this works. This is much better than the callback-based approach, but there's still pain here. There's still mess. This is not as clear as it could be. We're not expressing ourselves well to our fellow developers. So promises give us a really good model for asynchronous processes. Suddenly we've got a representation of a thing that was totally implicit. Some code that was just in your head that worked because you'd thought about it and you were pretty sure it worked, now had a concrete representation, a thing you could pass around telling you what was currently happening that allowed you to manage and actually use asynchronous processes directly. But the API itself, the interface for adding new steps to promises, for defining promises, doesn't play well with other constructs because constructs all build around function scope. This is JavaScript. We really like functions. When you have stuff like this that is fighting against functions, it's fighting against how you'd naturally write a lot of programs. So what we want to do is try and make this better. We'd like to keep that same representation, but build a better API on top. Before we do that, let's take a detour. Generators. Who's ever written a generator in JavaScript? A few hands at the back. Yeah, some sprinkled around. Generators are great. Generators are very exciting in lots of interesting ways. They're, again, part of ES6. They've been a bit slower to get implemented everywhere than promises, but they're now in every modern browser except iOS, I believe. But you can just start using this in a lot of stuff. It's really great. Promises are functions that can repeatedly yield values. So repeatedly return values, essentially. This is really interesting. You can have a generator that starts, that runs some code, spits out a value, and then saves all its state and just sits there. And then later you can resume it, and it will start from where it left off and continue, and then spit out another value, and do this again and again and again. And this gives us functions that pause. Code that runs up until a point and then stops, and that we can pause and resume. And this is really exciting. This is really cool. And this is a change from the previous run-to-completion semantics. You suddenly have a function that you can start, and that you're not going to necessarily get to the end of within the same event. You might run the second half of this function half an hour later. You've got a totally different model for thinking about these things. So what does this look like? If you want to define a generator constructor, you write something like this, function star, and then somewhere in there you're going to put a yield. So this is a generator that yields every number. It spits out 0, 1, 2, 3, 4, 5, 6, etc. If you want to actually use this, you go like this. So when you call that function, this is a generator constructor, technically at the top. When you call it, it returns a generator. Once you've got a generator, you can call .next. And when you first call .next, it's going to start at the top of that function, and it's going to run until it gets to a yield. So this first .next says, OK, n equals 0, while true. Yeah, that's true. Yield n. N is 0, so I spit out 0, and then I save all my state, and I stop right there. And what you actually get back from the next is the value that was yielded, if one was yielded, and done true or false. And while you're yielding, done is false, and if you throw an exception or you actually return, or just get to the end of the function and implicitly return, then done becomes true with whatever your final value that was there. When you then call next again, you start from where you left off. So we jump in at that yield again, with n still equal to 0. We say n plus equals 1, n equals 1, yield 1. And then we spit that out. And when you call next again, we resume from that same place. And we continue, and we continue, and we continue. And this lets you build functions that stop and resume later. Where this really becomes useful is for defining iterators. So you can write this for a number of generate every single number, and you can loop over every single number, which if you don't put if number blah, 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 will keep going forever. You can shoot yourself in the foot a little bit if you're not careful. All of a sudden, you've got an iterable that can actually be infinite. And you can do some interesting stuff with this. You can loop over any sequence you like and lazily generate that sequence. So you can loop over every prime number, this kind of thing, if that's something you really want to do. And this lets you write some quite cool code. For iterating, this is pretty interesting in a lot of ways. I don't really want to look at that very much here, but there's some interesting, neat stuff. Generators can also accept inputs. Not only do they spit stuff out, we can also push stuff in. That looks like this. So here, accumulator equals yield means once I get to this yield, I'm going to wait for you to call next with an argument, and then I'm going to accept that, and that's going to become the value of accumulator. This is a slightly messy API. You have to call next without any arguments first, and that runs the function up until the first yield, so then it starts waiting for input. And then we call sum.next1, and that 1 comes in and becomes the accumulator. We end up with var accumulator equals 1, and then it runs to the next thing and then pauses. So we get accumulator equals 1 while true, still true, var next addition equals yield accumulator. And this yield accumulator here, this is where it starts to get confusing, is going to both output that accumulator, so output 1, and then also wait for an input, which then becomes the next addition. And then when we call next 5, that becomes next addition, and accumulator plus equals next addition, and so on and so on. So this is slightly tricky. This stuff gets more complicated. You need to kind of play around with it to see how this works. But essentially, yield lets us input and output values at the same time, if you like, and pause as we do so. Every time you hit a yield, you save the current state of the function, and you output a value, and you potentially input whatever the next value is when somebody next calls next. So this is interesting, right? There's some cool stuff here. This is a bit crazy and not really how you expect functions to work in JavaScript. It's a bit of a weird, neat feature. Where it's really interesting, though, is that we're breaking run-to-completion semantics. We've got a function now that potentially could start and end over different events, and we could maybe model async in a different way if we can find a way to combine this and promises. So what we want to do is have that same model for promises, but a better API on top. So if we go back to our previous conditional example, we want to check if the server is up and the user's login is valid, then save the data and show a nice message. Otherwise, show an error. So this nice, simple process. And we'd like to redefine the expression of this, redefine how we describe this process, to use generators instead. So perhaps, maybe, we'd like to build an API that looks something like this. So we've got a spawn function that's going to turn this into a promise somehow. Let's ignore that for a second. And then we've got a generator that's just going to yield promises. It's going to run, and then anytime it's like, I need to do something async, it's going to output the promise for that async, and basically say, OK, resume me when this is done with whatever its value was. So we run up until our async operations, and then we say, OK, I can't keep running now. Here's a thing I need to continue. You take this, and resume me when that value is ready. And the spawn function is going to handle the gluing of this. So when we run this, it says, OK, start an if. All right, I need these two values. What's this first one? Yield is server accessible. That's async. Pause the whole function, spit out the is server accessible promise, and then later, when that's ready, give me back the value of that, true or false, and then check the other one, output that promise, get the value of that back, and then continue with these structures. And the generator is pausing step by step within this. How does spawn actually work? This is where it gets quite a bit more complicated, and we bring everything together. Spawn, you can implement spawn with this. This is pretty much out of the spec for the next stuff. I've skipped error handling here because this makes it a bit more complicated, but this gives you the underlying semantics for what we're looking for here. This is exactly how this works. When you pass spawn a generator, what you want spawn to do is run the generator, and then if it gives you a promise, take the promise, handle the promise, and when that's done, resume the generator and let it continue with the value you had. And that's what we do. We create the generator, and then at each step, we're going to call this step function with the result of the previous step. We initially call it at the bottom without any results because we don't have anything yet. And then we say, OK, run the generator with the current input and get a promise version of this input so we know it's a promise. If it's done, that's just our final value. We just return and we're done. If not, then use the nice promise API and just take this promise, and once it's finished, do this again. This is a bit complicated. This is a bit confusing. If you can dig into this and understand this, though, you can understand the entire model for the next stage. We're going to be looking at async await in a second, and the underlying model for that is just generators and promises. If you can put generators and promises together, this whole thing works, and you can see exactly how all the parts are moving underneath. And that gives us back this API. With that code, this works. You can just write that code, and now you can write async code like this. You can do this in ES6, and it just works. There's a library more productionizing this. There's actually quite a few. Task.js.mozilla has been quite a popular one for quite a while. But this is a much better model. This is much clearer code. We've still got a bit of mess around the edge. But in terms of describing what I'm actually trying to do, this gives you a much better idea. If this async thing and this async thing both come back with true, then run this async operation. And you've got a much better idea for the overall thing I'm trying to say when I write this code. It's particularly interesting here because while all of this is really promise-based, spawn returns a promise, all the things we're yielding to are promises, everything internally on how this works is promises, we're not actually using the promise API externally at all. Promises here are basically dead. We're not touching any of that external glue, but the underlying model is all promises. If you want to understand how this works, you have to understand promises. But if you want to just use it, you can just look at the high-level stuff, and it's very nice and readable. And it gives you a nice, well-documented, now reasonably well-understood API for how the underlying things work here, while letting you write in a much more fluent way that doesn't have any of these problems. But we can do this even slightly better for the last step here, with async await. This is the new JavaScript feature that takes this to its logical conclusion. This is a stage for draft proposal. That's the final stage for any proposal before it starts getting included in a formal JavaScript spec. the next JavaScript spec is going to be ES 2017, and they're going to be formalizing what actually goes into that from the end of January. And there are only 2 Stage 4 proposals, and it is likely that both of those and most of the Stage 3 stuff is going to end up in there. This is going to be becoming a formal part of JavaScript sometime during the next year. What this actually does is give you exactly the same magic. So what's actually happening is exactly the same. It's the same generators and promises model underneath, but with some nice syntax on top. That might just seem like a small change. It might not be that important that we've got a little bit of sugar for the tiny spawn function star bits. But trying to improve this stuff really improves consistency in the ecosystem. If you want everybody to resolve around the same way of doing things so that you can really easily pick up somebody's code and read it and know what's going on, then you need to start to settle on the same tools and approaches. Async await is an approach that's become quite popular in quite a few other languages. So C# has this, I think Python has this as well. And this is quickly becoming, across the industry, a very common way of describing async processes. And because of that, it's really good if we can start to build that consistency, start to all settle around a single way of this working. And building this ecosystem consistency by having it as a native feature really helps drive that forwards. It makes it much easier to read code and just know what it's going to do, because you've got this same implementation everywhere. You don't have different people with different spawn functions or any of that stuff. This actually looks like this. This is the same as the previous example, but we swap the yields for awaits, which are pretty much the same thing, and we change spawn function star into just async function. And that's it. You write code like this, and it does all that complicated promise stuff. It does all the way more complicated callback stuff you would have to implement this kind of thing, and it gives you a much clearer thing that is really, really very close to what you would have if you were a person trying to describe this code. If you were trying to tell somebody what this program did, you'd say almost exactly the words you have on this page here. If we look at some of the other patterns we've gone over, imagine perhaps we want to combine sequential results. Again, you get the user, and then you get the timeline for the user, and then you show the user, and you show the timeline. Nice, clear, fluent. We can express ourselves very, very effectively with this model. Finally, the third example, if you want to do async in a loop, that previous one that we were staring at for a lot more than 1.5 seconds is now really very clear, very, very succinct. We've got a list of results, and what we want to do is loop over the tasks and run each of them and put the result into results, and then return all of those together. And that's it. This just works. So, this is pretty great, right? Yes and no, there are some problems here. This is not all roses. We haven't managed to come up with a magical button that just saves the world. There are still a couple of things that are going to catch you out here. One of the major ones is that you can't use await in nested functions. So this is not valid code. Because this await in here is inside this other function we've passed a map, you're not allowed to do this. Your awaits can only be directly inside an async function. If you want to go further than that, then runtimes need to do some crazy stuff where any function is allowed to pause all the way back up to the previous async function, and they're not going to do that. That's going to be really hard. Nobody wants to put in all that work. This is a much simpler approach that solves pretty much all the same problems. If you start trying to support that as well, you also break run to completion completely. At any point, you could be called by an async function, and something you call could call await, and you don't know that's going to happen, and you're just going to pause in the middle of whatever you were doing. And people don't write JavaScript code assuming that it's going to pause in the middle. That will be very confusing. So you have to have this explicit async. What you might think is that you can just put async on that in a function, and then this would magically work. And that actually is not quite true. So if we try to do this, this doesn't actually work either. Here, this now is syntactically valid. But when you map over these friend IDs and call this async function, what that function is going to return is a promise. So your friend data array that you think is an array of data for each friend is actually an array of promises for data. Async functions return promises. They don't return values. And map doesn't understand this. So we need to actually handle this. Here, when we try and map over the friend data and get the name, we're actually going to be mapping over promises, and it's all going to go wrong. And what you actually want to do if you're doing this is fall back to promises. So you do have to understand the underlying promise model to be able to make this work. You have to see some of how the glue underneath pulls together. So here we just use promise all, we sort together, and say, OK, we're going to map over these. We're going to get the promises for all that data, and then I'm just going to await the whole lot, pause until this is done, and then I'll run the next bit. And with that relatively small change, this stuff works, but you do have to be aware of this if you try and manage this kind of thing. You also still need to be catching errors. Again, this is just promises. If you forget to put a catch at the end of a promise, it's quite easy for errors to just disappear into the ether. Dev tools have got quite a lot better at this now. If you have a promise that doesn't have a catch anywhere and it throws an exception, Chrome, for example, will tell you that you've got this uncaught thing in a promise, but you're still not in a position to actually handle that. And you need to be thinking about that here. And it's easier to not think about it because it looks so much like synchronous code. It's really easy to call one of these and assume that if they explode, your try-catch around it is going to get it, and it's not. It's still asynchronous code. Fundamentally, it's still doing the same thing as promises. It's a different API over the top for defining them, but the runtime model is the same. Finally, it can be very easy to overuse await here. Now that it's so easy to just treat these things as synchronous operations, you can just do a bunch of stuff and await this, await this, await this, await this, await this. And because you don't think about that, you end up doing a bunch of sequential operations that could be parallel, that don't need to wait for each other, that become very slow. You can accidentally write very, very sequential things that will sit and block, not block, but wait for each of the individual operations along the way. And you can write slower code, just because it's easier to not think about performance here. So you need to still be thinking around the same kind of things you would be if you're doing this with callbacks or promises. But other than that, it's pretty great. It would be nice to start using this so that people understand what the hell the JavaScript we're writing actually did. If you want to do this, amazingly, the best place is Edge. In an astounding twist, Chrome also have this totally implemented and up if you tick the experimental JavaScript flag. And I don't think they've announced anything, but I strongly suspect they'll put this live as soon as it's included in ES 2017 at the start of next year. Firefox and WebKit have implementations that are basically there, but they still need to actually finish those and bundle them together. WebKit actually had a finished working implementation, but had some performance problems, so they're tweaking it and this kind of thing. But all of these are very close. Very, very soon, certainly I would expect within the next 6 months, all the major browsers are going to have this live and ready to go, and you can just write JavaScript that's going to work in these. Obviously, that doesn't help you that much if you have to support anything except the most cutting-edge browsers, or if you want to write any code in the next 6 months. But support for compiling back to this, back from this is pretty good. So Babel will take this and compile it back into the generator equivalent that we've seen, and then we'll compile that back into ES5 if that's what you're looking for. TypeScript will happily support this kind of stuff as well, but only compiling it back into ES6, so you have to be prepared to output ES6. But you can go from there and compile with another step, or TypeScript 2.1, which I don't think has a release date either, but is coming soon-ish, is going to support taking this right the way back to ES5. So there are quite a few practical options for using this right now. It's quite fun to play with, even just in the Spawn version, which will work anywhere that generators work. And very, very soon, this is going to become the standard way of doing things. With this now, we actually have high-level async constructs. When you're writing async code, you don't glue together a bunch of callbacks that you're pretty sure are going to work. Instead, you write async blah, 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 and you say await, 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 and somebody looking at it says, this function runs this code, and then it waits here, and then it continues. I know how that works. That makes sense. People can read this code, and the ideas you were thinking, the models you were using when you were writing it, easily come into their minds. They can see what you're doing, they can understand your code, and they can see the important parts of what's really going on here. I want to close with a great quote from Structure and Interpretation of Computer Programs, which is kind of classic computer science textbook. Programs need to be written for people to read, and only incidentally for machines to execute. There's a lot of really cool stuff we can do to make some machines execute some really crazy things. And those are really fun, but the really hard and important problems in computer science are trying to find ways to express these so that other people will understand them. Trying to describe programs so that other people can see what you were thinking, so that they know what's going on, so that we can maintain the software, so that we can build the software better, and so that we can build software faster and get stuff into the hands of our users more effectively. Thank you very much.
you, Tim. Wow, a lot in there and covered in great depth as well.
I'll put the slides out on Twitter later so people can take a look through the examples. The spawn bit particularly gets a bit confusing, but it comes together.
Oh, it's always nice to have the code examples out there.
Yeah, yeah.
Any questions, anyone? Oh, brilliant, we've got a few. We go here first.
Hey, thank you for your talk. I have a question about the nested functions. Does this also apply for arrow functions?
Yes, it's exactly the same. So you can put async arrow, and
No,
you can
I
write
mean
that,
for
but the same problem exists. Yeah.
Since even they have no scope.
Yes, you can. It's very difficult to come up with a model where that is okay. Otherwise, otherwise, if you define an arrow function in a variable outside, then you pull it in. Is it allowed to use await? This kind of thing. So it's just not allowed. You can only use await directly inside an async function.
Okay, thank you.
And there's a question in the middle here. Good luck.
Not too difficult. So you introduced two new reserved keywords, await and async. Naturally, that suggests that they can be used independently. So you could have something await without async and async without await. That's actually what you could do in theory. But I guess from your examples, that's not actually what we should do. So is there... Would there have been is there a mischance to project one from the other?
So I don't think there's any cases where you're going to be able to use await without async. Fundamentally, it's a syntax error. You're not
So it could be
allowed
the
to do
nearest function. It could be projected automatically on the nearest function in scope.
There are different ways you could define JavaScript where that could work, but we're not going to do that. Async, you could use async without await if you'd really like to. And there are some interesting cases where that's actually kind of useful if you want to magically turn something into a promise without really having to wrap it in a promise, but it's still synchronous code. But it's some special cases. It doesn't really ever come up. You're almost always going to be using them together. But it's valid to do so.
Any more questions? Oh, there we go. Martin at the back.
Hi there. Thanks for the talk a lot. That was great. Quick question is, now I may see a legacy code base with a lot of callbacks. What would you say is the best strategy to get out of the callback hell as quickly as possible?
Panic. So there's going to be a few steps in this. I think the first and most important thing is transforming stuff into promises. All of this stuff underneath is still using promises. Once you've got it into promises, the transformation is actually really easy, and you can do it very locally, or however you like. Transforming into promises is the hard bit. So breaking through that step first, bit by bit, is the important step. There's some good libraries for promisifying things. I think ES6 Promisify will just nicely do that. You need to be running in an environment where you can use promises, or you need to be bringing in Bluebird or one of the kind of promise polyfills, promise libraries that are going to allow you to do that. But once you're in that place where you've got promises, actually transforming to async is really nice. You can just put it in individual functions where it's useful, and you can start spreading that. And you can just call your normal promise-based functions in async, and that just works. And async just returns promises, which is probably the same thing everything in your code already expects by that stage. Once you've got to promises, it's pretty easy, and it's focusing on that first stage. That's the hard part. Cool. Anybody else?
Oh, there's one over here.
One in the
How could we
corner.
miss you?
Yeah, maybe it's just too early in the morning, but I didn't really get how the error handling is going to work with async and await.
Okay, so the model underneath it is the same as promises. If you want, you can have an async function, you can call it, and then you can put .catch, blah, and just catch stuff. So you can just treat it exactly as you would for promises. At the same time, though, inside that function, it's just the same as any normal synchronous JavaScript function, and you can just write try catch around things. And again, stuff will just work like that. So you've got these two options. It's going to depend on your different use cases, particularly if you've already got your error handling set up and you're trying to move to async from promises. It's probably going to make more sense to stick with the catch bits. with the explicit promise catches, sorry, but eventually I'd expect more people are going to start moving to try-catch and bringing all of their code into the same kind of error handling patterns, whether it's synchronous or asynchronous or whatever, hopefully. Any more for any more?
Anybody?